Mars, once a warm, watery world with a thick atmosphere. Now, a cold, arid landscape with its atmosphere thinned out. What caused this transformation? Over billions of years, a relentless flow of particles from the sun, the solar wind, has slowly stripped away the Martian atmosphere, causing surface water to evaporate. But how exactly did this happen, and how could it affect future Mars explorers? NASA's new ESCAPADE mission aims to find out. The Escape and Plasma Acceleration and Dynamics Explorers mission is studying the planet's real-time response to the solar wind, helping us understand Mars's climate history using 2 spacecraft in orbit for the first time.
Past missions that we've sent to Mars to understand the interaction of the solar wind with the planet have only been single spacecraft missions. So ESCAPADE gives us what you might call a stereo perspective, 2 different vantage points simultaneously. This will allow us to really make measurements we've never made before and to characterize the system in a way we couldn't characterize it before.
ESCAPADE's twin spacecraft fly in 2 different formations to see how Mars responds to the solar wind in both time and space.
This is the first time that 2 or more spacecraft have worked out a formation in orbit about another planet, in this case Mars.
In the first formation, nicknamed the String of Pearls, the 2 spacecraft chase each other in nearly identical, highly elongated orbits. This allows ESCAPADE to observe rapid changes in the Martian atmosphere caused by sudden variations in the solar wind.
When we have 2 spacecraft crossing those regions in quick succession, we can monitor how those regions vary on timescales as short as 2 minutes up to 30 minutes. Before we had to wait for 4, 5, 6, 7, 8 hours.
In the second formation, the spacecraft have different orbits that are more separated from each other, allowing ESCAPADE to study both the solar wind and the upper atmosphere of Mars simultaneously for the very first time.
We'll have 1 spacecraft in the solar wind so we can measure what's coming in, and then 1 spacecraft closer to Mars. This will help us understand the cause and effect of what's happening when space weather comes to Mars.
ESCAPADE will not only fill gaps in the story of how Mars's atmosphere changed, it will also help us prepare to send human explorers to the Red Planet. For example, ESCAPADE will give scientists more details about Mars's ionosphere, a part of the upper atmosphere that future astronauts will rely on to send radio and navigation signals around the planet.
Understanding how that ionosphere varies will be a really important part of understanding how to correct the distortions in those radio signals that we will need to communicate with each other and to navigate on Mars.
ESCAPADE's work could also help keep future Mars explorers safe.
Atmospheres can provide a shield that protect humans and other assets on the surface from things like solar radiation or intergalactic radiation. So it's important for us to understand how the atmosphere is changing in order for us to know what we have to do to protect humans and other assets we might put on the surface.
In addition to new science, ESCAPADE is pioneering a new way to reach Mars. Previously, spacecraft launching to the Red Planet had to wait years for Earth and Mars to line up. However, ESCAPADE is launching into a unique orbit that loops around a region in space known as L2, roughly 1 million miles away. Then, it'll return and use Earth's gravity to slingshot itself to Mars. This allows ESCAPADE to launch early and wait in space until the 2 planets are in the right positions. This first-of-its-kind orbit will also make ESCAPADE the only spacecraft to ever pass through a distant part of Earth's magnetotail, before beginning its 10-month cruise to Mars and starting its cutting-edge work there.
NASA's heliophysics fleet is looking at the sun's influence, and with ESCAPADE, we'll now have multi-point measurements at Mars, which will help us have a more comprehensive picture of what's happening throughout the solar system. We need a solar system-wide understanding of space weather in order to protect our technology and our astronauts wherever they go.